Hello and welcome again, guys. Now that we understand how to build a publisher and subscriber from the previous video, let's build on top of that and now understand how to make services and service clients in ROS2. Let's begin. In the first part of the series, we built a publisher and a subscriber in ROS2 using Python. In this video, we will build a service and a client, as I said. Now, if you don't understand what services and clients are in ROS or ROS2, this is the video you should check out. But just to summarize, a service in ROS or ROS2 is a way for you to request for some task to be done from some specific node. For instance, in our example which we'll build right now, we'll have one node which has a service to add two integers and send the result. So from outside, what we'll do is we will send two numbers to this node, or to be very specific, the service of this node, and the service will return back the addition of two numbers. The question is, where are services used? There can be many instances where a service is used. For instance, let's say in a real robot, there is a node which knows the actual position of the robot, but it is not disclosed outside. To request this position, what we can do is we can have a service in this node, and then from outside we can query using this service. So a service client will ask for the position of the robot, and the service in this node will respond back with the position of the robot. A second use case is where you want to send something to a node, and then based on what you're sending, the node will use that information to do something and return something back, which is the classic example we are using even for this video, where we send two numbers and then this node will manipulate these two numbers, which in a simple example means adding these two numbers and sending back the result. So this is where a service or a service client pair is usually used. Service is the place where the actual task takes place, and client is the requester of this service. And this is the design of our simple example in this video, where there will be one node which will have a service which is responsible to get two numbers, add them and send back the result. The other node will have a client which will request for this addition. So it will send two numbers to the service. Now this is not complicated, right? So let's start building right away. But before we start building, we also need to understand what we actually need. To make this service client pair in ROS2, we need three different things. The first one is your service node, which will host this service. The second one is your client node, which will have this client. And in our example, both of these will be in the same package. So the service node has one node to take in two numbers and send the result. The client node has another node in the same package, which will send these two numbers as a request to the service. The third part is making something called a custom interface. Now, whenever you make a publisher, subscriber, service, or service client, you also need to tell them what data structure or message type it should use. Now, in case of topics, it's called a message. In case of a service, it's actually called a service. So we need to create a service file which will define this data structure, and the service file will look like this. The top part is two integers, which is something to be sent to the service, and the lower part is the result of that. So we see A and B, which are inputs to the service, and then the output is response. Unlike ROS1, there currently isn't a way to generate a message or a service file in a pure Python package. And that's why we will have to create a custom interface in a CMake package, and then we'll use it in a Python node. So this custom interface, which effectively for us means the service file, will be made in a CMake package. So we'll have two packages, one Python package for our service and client node, and the other package to make this custom interface to define what kind of data is being transferred between them. So let's begin building this. To make this project, we need to start with a ROS2 workspace. So I'll make a ROS2 workspace here. It's called a ROS2 workspace, and the src directory will hold all our packages. Now let's go to our ROS2 workspace. Let's source Galactic before we do anything. So this is how you source ROS2. My distro is Galactic, so that is for me. Now let's ignore this because I also have Noetic in my system, and that is in my bash rc script. But this is how you source ROS2. I have an alias which is sgalactic, which does the same thing, but in your case, you need to use this line source opt ros galactic setup.bash. Now let's build this workspace which has no package. So zero package is finished, right? Because it has no packages right now. Now let's go to a src directory. This directory will host all our packages. And as I said before, we have two packages. Now let's go to VS Code and start building everything. But before we start coding here, we need to make these packages. So let's go to the terminal again. Let's first start with creating a service file in a new CMake package called custom interfaces. This is how you make your CMake package. So we have our custom interfaces package. Now the job of this package is to just have a service file. To have the service file, we need to make a new directory called srv. And inside this directory, we will have our .srv file. I'll name this service add to ints dot srv. And as I showed before, this is what the service file looks like. Let's just zoom in a little bit. Now this is our service file. The next thing we need to do is edit our CMake lists. To generate this interface when the package is actually built, this is what we need to add. And it depends on this package. So this is what we need to add so that we can use this service file everywhere. Next, we need to make changes to package.xml. So this is what we need to add so that we can use this package and then effectively use this service. Now at this point, this package is actually ready. So we need to build this package right now. Let's go to our ROS workspace and call con build. So this package was built. To confirm if this service file is visible to ROS2, we have to first source this package. So source the workspace. And then we need to use the command ROS2 interface show followed by our service. So this is ROS2 interface show, then the package name. Custom interface is srv add to ends. Let's see. ROS2 can see the service then. So we are done with this package. Now the other package has all the core functionality, which means one node for service and one node for client. Let's go to the core of this video then. So to create a new package, we go back to our src directory. In our src directory, we make a new Python package called, let's say, add integers. So this is how we create a new package called add integers. This will have one service node and one client node. Now it depends on RCLPy and custom interfaces, which we just built right now. Because we have this flag dependencies with RCLPy and custom interfaces, CMake lists file and package.xml will already be updated with these two packages. So let's make this package. Okay, so we have our empty package. Now let's start making service and client nodes. Let's start with the service node first. The job of the service node is to have a service inside it for this example, which will take in two numbers or two integers and then send back the sum of these two integers. So inside the package add integers, you have a directory called add integers. This is where we have our new node. Service node.py. Let's start with importing whatever is necessary. The first import we need is RCLPy. I can zoom this a little more. RCLPy is needed because if you want to do anything in ROS2, you need to use ROS client library and we are using Python, so Py. The second one is node because when we'll make our ROS2 node here, it needs to inherit from this node. The third one is add to ends from the custom interface package we just made. So this is your srv file. Now let's make main. Let's define the function main. In main, as usual, we start with initializing the context. Let's have args equal none. So this is where you initialize your context. Now we need to do three things. The first one is create node. The second one is use or spin node. Spin is how you use a node. And the third one is destroy node and shut down the context. So to create the node, we need to make our class for the node, right? So let's start with that. This is your class for the node. I'm calling this class addition service. Let's make the constructor here. Inside the constructor, we need to initialize the parent class. The name of this node will be add_int_service. Now we also need to make a service inside this node, right? Because that's the idea, make this interface service. So this is your service here. The first argument for this method create service is add to ends, which defines the data structure of your service. The second one is the name of the service, and the third one is the callback. Now in a service, whenever someone will request for this service from the outside, the callback add to ends callback will be called so that it can be served and then it can return something which is the result of that service. So let's make this callback now. So this service will have two arguments. One is request, which will hold information about the request being sent. So in our case, it will hold information about the two numbers being requested to add. And response is something this service populates. So in our case, this response will have the sum of these two numbers and then we return the response. So we can do simple addition of these two numbers. Now you saw in the srv file that the input was a and b and the output was sum. And because of that, we used the same naming convention. And then your response.sum is request.a plus request.b. Now we'll return this value. So this is what this callback will do. This is simple. Let's also print this information. So we'll use getLogger to print this information on the terminal. Let's print the two numbers this service got. Okay, so whenever this callback is called, which is when the service is requested from the outside, then we'll see this line on the terminal, incoming request with the two numbers. We have the class for this node ready. Let's create the node now. So this is an instance of your addition service node. To use this node, we spin this node. Now, as I said in the previous video, you have to spin a ROS or ROS2 node for it to work. Now, when you spin, what happens is all work associated with this node can be executed based on how you're spinning the node. Work can be subscription callback, timer callback, service call, receive client responses. In our case, it's a service call. So that's why we use spin here. Now, after spinning, we need to destroy the node towards the end of everything, right? When we are done and then we want to end the context. So we destroy the node and then shut down the context. So this is how you destroy the node and then we'll shut down the context. Okay, I'll remove these comments now. Now to use this node, we need to make changes to setup.py. In setup.py, we need to update entry points. If you've seen the previous video, you know why we need to do this. So this is how the executable becomes visible to ROS2 so that it can actually use this executable for the node. Here we have addition service, which is in the directory add integers, and then service node is the name of the file, and then main. So everything starts with main, which is the entry point. Now our service node is ready. Let's also make our client node and then build everything and see what happens. To make a client node, we go to the same directory called add integers. We make a new file called client node. So client node.py is the new file. And this one will have our client node. Client node will request the service from the service node on the same service name. It will send two integers and get back the response, which will be the sum of these two integers on the service. Instead of hard coding, what we'll do is we'll run this client node from the terminal and also give two numbers from the terminal so that it's not hard coded and we can send different numbers and get the response, which will be the sum of these two numbers. Let's start with importing everything which is needed. We import these three like our service node. Let's also import sys, which will help us get the numbers from the terminal as arguments. Okay, so we have all our imports ready. Now let's start with main. Let's define main. Here we do the same thing, initialize the context first. Let args be none by default. Now we do the same thing, create node, use spin node, destroy node and shut down. Now to create a node, we make our class. This class is called addition client async. Async because the service call we'll make from here will be asynchronous. What do I mean by that? Normally what we'll do in ROS1 is we will request a service from a specific service using a client, and then we'll wait for it to send back the result. But that is not what we want here. What we'll do is we will send this request and then we'll come back and execute whatever we want, but we will have a handle on what has been happening under the hood. So we can always know that, hey, the service request was completed using something called an asynchronous call. Asynchronous calls are not specific to ROS. They are available in C++ and Python. So if you want to know more about asynchronous programming and asynchronous calls, you can look it up on the internet. There are brilliant resources for that. Now there is one other reason we need to use an asynchronous call and not a synchronous or a normal call. That is because everything is happening here in a single thread. So if you use a synchronous call, we will keep waiting for the result, but that will block the spinning of the node itself. You'll understand why I'm saying this when we start building this. But the idea is there will be a deadlock situation if you are requesting for a service synchronously and also trying to spin the node. Now coming back to this, let's just make the constructor. Let's initialize the parent class. The name of this node will be addition underscore client underscore async. Now we need to make a service client here. This is your client. The method create client takes in two arguments. The first one is your service definition and the second one is the name of the service. Of course, this name of the service has to be the same in your service node and your client node. Now, when we use this client and create an instance of it, it makes no sense for it unless the service is actually active. So right now in init, we'll also check if the service is active. If not, then it'll just keep waiting for service and it won't be doing anything else until then. So here what we're doing is while the service is not active, which is checked using self.client.wait for service with a timeout of 1 second, we will keep printing service not available waiting again. So every 1 second, these two lines will check if the service is active. If not, we'll just keep waiting until this happens. But once the service is actually available, then we are done with our initialization. Now we'll also have a method which is for sending the request. When we want to send the request, what we'll do is we will pack all the information, which in this case will be two numbers A and B or two integers A and B, and then send it using an asynchronous client call. So let's make a method called send request. Here we will pack our information, which is two integers a and b. So let's make a request data structure and then populate it. Now the first part A for this request from the data structure add two ints is the first number we send from our terminal, which will be sys.argv1. The second one is B, which is the second number from our terminal. Now we need to make an asynchronous request to the service using this client. This is how we make an asynchronous request to this service. Here you have something called call_async, and then you send the argument, which is your populated request. Now you see something called self.future. For an asynchronous call, this future is a handle on the state of this request. So instead of just waiting on line 19, what you're doing is line 19 will be executed irrespective of how much time the service is taking. So let's say the service is actually taking 10 seconds. It doesn't matter. The code will not stop here and wait for 10 seconds. Future will have a handle so that whatever we are doing even after this, we can come back and check this future to understand if this request was actually completed. Now you'll see how we want to use this in a bit. Let's create a node before we can use all of this. Now after creating this node, the immediate thing we want to do is sending the request, because that's the idea, right? From the terminal, we'll do ROS2 run with the name of the node and then also send in two numbers. So immediately once this node is created using that command, we will use send request to send these two numbers. Now send request is used. So that means that after line 27, we will have a handle on this future. So we can come back and check if this task is completed. Now all of this will be done if the context is fine. So we'll do everything now using rclpy.ok. So while the context is fine, we will spin the node, because without spinning the node, a node cannot function in ROS or ROS2. Normally you would have seen rclpy.spin. We cannot use it here. Why? We have to use spin once instead of spin, because if we use spin, it will block everything. Spin is a blocking call. But right now if we use spin, we won't be able to come out of line 31 and check if the future is done. And what spin once does is, it executes a piece of work once. Let's understand this a little better by looking at different kinds of spins in ROS2. Okay, here we want to understand what is spin, spin once, and spin until future complete in ROS2. Spin is how you execute a node where the context for this node is completely blocked until it is shut down. So when you use spin, then only the callbacks can be called based on whatever service request or publishing is done. Here work can be a subscription callback, a timer callback, a service call, or a receive client response. So if you have one of these, that is work for this node. The most important thing for you to remember is this spin is blocking. So you cannot go out of it once you're inside. The second one is something called spin once. So instead of blocking the context completely, it will execute one item of work where we now already know what work can be, or it can wait until a timeout expires. So you can actually give an argument called timeout, which says that, hey, you need to wait for these many seconds. Within that seconds, you either execute a work, let's say a subscription callback, and then come out of it, or if there's nothing for that amount of seconds, then you come out of it irrespective of anything else. But remember that one callback will be executed, not all of them. So as soon as one callback is executed or the timeout expires, spin once is done. The third one is spin until future complete. This one is used in asynchronous calls where you have a handle on the future of this asynchronous call. Let's say you have an asynchronous service call. Now until the future is complete, that means until that task is done, this spin will be blocking. That also means that for this method, you need to give the argument future so that it can constantly check if that future is complete or that specific task, that specific asynchronous task was done. So as a summary, spin is blocking. Spin once is blocking only until one work is done or the timeout expires, and spin until future complete is blocking only until the future which you send is complete. So one task which you specify is complete. So that's the idea behind these three spins in ROS2. So coming back to this example, we use spin once so that once our asynchronous call is complete, we are out of it. If we use spin, there is nothing else we can do after this line, which will be a functional piece of code. Right now, the spin once will be completed if you have your asynchronous call done. So you'll have a handle on your feature so that you can also confirm that later. So here we confirm it. So this is how you check if your asynchronous call was complete. Although the asynchronous call is complete inside this if condition, we need to check if the response was valid. So for that, we use try except. So we'll try to get the response. If the response was valid and there was no error thrown, it's fine. If not, we'll throw an exception. So this is your exception where we say that, hey, the service call failed. But if it doesn't fail, let's print something. So if it doesn't fail, we go to else condition where we actually print the result of this addition. But now irrespective of what happened, either service call failed or the result of addition was given to us, we need to break, right? Because once we send two numbers from the terminal and then it sends us the response, the job is done. So this client has no use anymore. So we break here, which means that we're out of this while loop of rclpy.ok. And then in the next line, we destroy the node and then shut down everything. So this is how we destroy the node, and this is how we shut it down. So that's the idea behind this client node, which will use an asynchronous call to request the sum of two numbers from the service we made some minutes back. Let's remove these comments. Okay, so our node is ready. Now let's make changes to our setup.py file again so that this node is visible to ROS2. Like addition service, we do this for addition client. So you have your directory add integers and then client node file and then main. So looks like this is done. Let's try building the package to see if everything was fine. Let's go to our ROS workspace. Call const build. So 2 packages finished. Looks like everything is fine. Now let's try running the packages to see if everything is working fine. If everything works fine, then we will demonstrate the idea of a service client requesting the sum of two numbers from the service. Let's have 2 terminals here. So let's source both the terminals. First source ROS2 here, and then let's source the package. And here let's run our service. So ROS2 run. Name of the package add integers, and then your service is addition service. Okay, looks like everything is fine for addition service. Let's now use our client. So in the other terminal, let's source the package. ROS2 was already sourced, so I'm not doing that right now, but let's source the package and then let's run the client. ROS2 run add integers, which is the package name, then addition client. As I said before, we need to give 2 numbers, right? Let's give 1 and 2. So you see something is happening here, right? So what happened is on the client side, you see result of addition is 3. And on the service side, you see incoming request 1 and 2. And this is what we printed on the terminal, right? So this is how it works. So right now we demonstrated the idea of making a service and an asynchronous client in ROS2. We also understood how to make a custom service definition using a different CMake package. We also understood what spin once, and spin until future complete is in ROS2. So I hope this video gave you a good idea about making services and clients in ROS2. After understanding how to make publishers, subscribers, now also services and service clients, we need to go to actions. But actions is something I think after all of this, you can understand on your own and build on your own. I have a text version of the tutorial to understand how to make ROS2 actions from scratch. I'll add my Medium blog link in the description of this video. It'll help you making an action from scratch. In the next video, we'll understand how to make a launch file, because right now we are using ROS2 run for all your nodes, but we need to make a launch file to use these nodes. And that is the best way to go about using any package or any node in ROS2. So in the next video, let's see how to make launch files. Thank you so much. See you again soon. Bye-bye.